Okay, so in question 5, you're supposed to determine if this is a function or not a function. So what I do is I look at each of these x values. These are your inputs. And to be a function, each x has to be assigned a y. Okay, so each of these x's, which are my domain, so I might as well write that in right now, has to be assigned with one y value. So 2 goes to 4, that's the range, that's the y value. 3 goes to 5, 4 goes to 6, 6 goes to 4. So there's no ambiguity, is a fancy word, but there's no question about what 2 is assigned to. There's no question as to what 3 is assigned to. If I say the input's 4, you know the output is 6. If I say the input is 6, you know the output is 4. It's not like, well, it could be this or it could be that. No, you know when the input is 2, the output is 4. So that's all right that 4 is used twice in the range, because 6 can go to 4 and 2 can go to 4. As long as each domain just goes to one range, that's okay. So is it a function? Yes. So now look at D. And so all of these, or part B, all of these parts in here are the domain, all these are the range. So the domain are all these test scores, 90, 80, or grade scores, or whatever they happen to be. So those are all the domain. These are all the inputs. And the range are all these possible outputs, which in this case it looks like are grades. So these are all the possible outputs. So think about this for your own self. If you had a percent of 80, you'd want to know, well, what grade do I get if I have an 80? And so up here we look at 80 and it goes to B. Well, what happens if I have a grade of 70? You want to know, well, it looks like I have a B minus. Looks like if I have a 60%, I still have a B minus. But then you get to 50 and it's like, oh, well, I have a C plus or a C. So does this just depend on the mood of the teacher that day, or how does this work that I could have two different grades? So that's not good, because when I say my input is 50, you want to be able to say I have this output. Not, well, it could be this or it could be that. We want to know for sure what it is. So since 50 goes to two different things, that is not a function. So now look at part C. This thing, if I were to say my input is -5, what's the y value? Well, I'd come up here. Oh, look, it's this y value. And then I come down here, and oh, it's this y value down here. That's not good, because for this x, it could be two different y values. That is not good. That's not a function. Now, the domain on this is this goes to the left to 6, and it goes to the right until 6. The range, it goes down to 6 and it goes up to 6. So that's the domain and range on that one. On this last one, the domain are the x coordinates 1, 3, 5, 7. Those are my input. So 1, 3, 5, 7. And my output is 5s and 3s. So my output is 3 or 5. That's my range. So 1 goes to 5, 3 goes to 5, 5 goes to 3, 7 goes to 5. So each domain is assigned one specific range. So therefore that is a function, because each one goes to something specific. We don't have to be like, well, it could be this. No, we know when the input is 1, the output is 5. So that's what makes that a function or not a function. All right, number 6. It says find the indicated value for this given function. So here's my given function. The first one says find f of -5. So see how this x has been replaced with -5? That means I need to replace the x's over here in the equation with -5 as well. So that means I have 3 times -5 squared plus 13 times -5 minus 10. So -5 squared is 25 times 3 is 75. 13 times 5 is -65 minus 10. So I have 75 minus 75, which makes 0. So f of -5 is 0. So if you're thinking about this, the other cool thing about that, maybe not cool, but interesting, or maybe not even interesting, just another fact, if the x value is -5, the y value comes out to be 0. So what that is saying is this is an x-axis, or an x-intercept. So if I were to having to graph this thing at -5, I know the y value is 0. Anyways, just a thought on that. So now I'm going to plug 3 in for x on this one. So I have 3 times 3 squared plus 13 times 3 minus 10. So 3 squared is 9 times 3 is 27. 13 times 3 is 39 minus 10. So that's 27 plus 29. So that makes 56. So in other words, when x is 3, my y value is up here to clear up here at 56. So now on part C, it says f of x minus 2. That means I'm replacing all these x's with x minus 2. So I'm going to have 3 times x minus 2 squared plus 13 times x minus 2 minus 10. So x minus 2 squared, we do that because the order of operations say we do exponents first. So that squared means I have x minus 2 times x minus 2. So x times x is x squared minus 2x plus 4. And that's all still going to have 3 distributed into it. Now I'm just going to take -2 and -2 and make -4. So that makes 3x squared minus 12x plus 12. Now I distribute this 13. That makes plus 13x minus 26 minus 10. So now I combine like terms. There's no other x squared, so 3x squared, -12, positive 13. That makes positive 1. And you can just put x. You don't really need to put the 1. I just did for some unknown reason. I don't know what possessed me. But anyways, that's a 1x. 12 minus 26 is -14. Minus 10 makes -24. All right, the last one, I'm running out of room, so I'm just going to do it down here. It says to replace all the x's with 2m squared. So I have 3 2m squared squared, because remember I just replaced the x with 2m squared, so there's still the squared on the outside. Plus 13, 2m squared minus 10. So 2m squared is 4m to the 4th. So 3 times 4m to the 4th is 12m to the 4th. 13 times 2 is 26m squared minus 10. There aren't any like terms to combine, so that's as simple as that one goes. All right, number 7, domain and range for each function. So on this one, if I were to graph this, pull out your calculator and graph it, it would be a parabola that has been moved down -3. So the domain on this thing is going to keep going to the left forever and to the right forever. The other way to look at it is there are no fractions, there are no square roots, no fourth roots, so there are no problems. I can use all x values. So the fancy way to write that is from -infinity to infinity. The range. If I look at the range, the bottommost y value is at -3. So -3 to infinity. The other way you could do that is plug 0 in here. 0 squared minus 3 is -3. That's the lowest value, because when you plug 1 in, you can have 1 squared minus 3, and then 2 squared, so forth. Those numbers are getting bigger. So you can see that there's not ever a lower value than -3. Part B, if I graph this thing, so if I go to your calculator and you graph it, it looks like this. And so I can see that my domain values are everything from -4 to the right. The other way that we do that is we just say that this has to be greater than or equal to 0. -4 minus 4, x is greater than or equal to -4. Or I can look at my picture. So my domain is -4 to infinity, because it can equal -4. -4 just makes it 0. If it could not equal -4, it would have a parenthesis there. My range, looking at my picture, I see that there's no values less than 0. And if I were to plug -4 in, I get -4 plus 4, which is 0. So the square root of 0 is still 0. So the bottommost range value is 0. And it keeps going up forever. Part C, let's just pull that up on a calculator so you can see what it looks like. parentheses, x squared minus 9, all divided by x squared. Go to your graph. So it looks like it's pretty flat along here, almost 1. Then it dives down at 0, and then it comes back up and flattens back out. So that kind of gives us an idea of what's really happening with this equation. Now I want you to think about this. If I plug in some values for x, say I were to plug 10 in here for x, I would have 100 minus 9 over 100. So this is always going to be the same number. If I plug in like 5, it's going to be 5 squared minus 9 over 5 squared. So realize this top number is always going to be 9 less than the bottom number. If I plugged in 100 for x, I'd have 10,000 minus 9 over 10,000. So whatever the top number, like these two numbers are the same, but the top number is always 9 less. So thinking about that, that's always 9 less, which would be 9991. This would be 16 over 25. This would be 91 over 100. This top number is always smaller than the bottom number. Always. Because it's 9 less. So you think about that. In order to be 1, they have to be the same. Like 10,000 over 10,000 would give me 1. To be more than 1, the top number has to be bigger. Like that's going to be more than 1. So by virtue of the way this is set up, it is never going to be bigger than 1. So I know that that's never going to be bigger than 1. So when I looked at my graph and I saw that it looks like it gets close to 1, it probably does get close to, but it never goes over 1. So that helps me with my range. My range, it went down forever and it got close to 1, but it never actually gets to 1. And the domain, x cannot equal 0 on the bottom of a fraction. So my domain is negative infinity to 0 and 0 to infinity. A little u in between them. Now in part D, we can look at that on the calculator as well. Y equals 5 divided by parentheses x minus 3 graph. So right at 3, it takes a nosedive, and then it picks back up here, and it looks like it never crosses 0. So if I come to this, I know that x cannot equal 3. Okay, so on my domain, it's negative infinity to 3 and 3 to infinity. And there's nothing I can do. I cannot divide 5 by anything and make it equal to 0. If you can think of something, let me know. But I cannot think of anything that I can do to take 5 and divide it by some value down here that will make 0. So my range will never equal 0, which we saw in our graph. So my range is negative infinity to 0, union, that should be union, 0 to infinity. Number 8. So number 8 says, oh, my pen's going crazy. So number 8 says these are our domains. In other words, these are our inputs. What are the output values? So realize the first thing is that negative 3 means I flip this upside down. It's 1 over x cubed. So these are the values we're going to plug in for x. So that means I have 1, negative 3 cubed, 1 over negative 2 cubed, 1 over negative 1 cubed, 1 over 0 cubed. Anything over 0 is undefined, so we know that that's undefined. 1 over 1 cubed, 1 over 2 cubed, 1 over 3 cubed. So a negative times a negative makes a positive 9, times another negative 3 makes a negative 27. So negative 1/27. 2 times 2 is 4, times another negative 2 makes a negative 8. 1 times 1 times 1 is still 1. So 1 divided by negative 1 is 1. Then we know it's undefined. And then it's 1 again. 2 times 2 times 2 is 8. And 3 times 3 is 27. So that's the answers to that. Kind of sloppy on the end, but that's the idea.